Now we're going to go ahead and start. So as the title says, we're talking about avoiding launch fails with a little bit of spoiler. We're going to be looking specifically at a tool called Locus.io. We're also going to be talking a lot about performance testing, load testing, and how to test that your software will scale with real-world usage. Like with everyone, we have a code of conduct at the conference. If you have any issues, you can follow the link up there. I'm pretty sure that's Mike's phone number if you have any concerns or want to call anything out.
So, I guess my actual name isn't on here, which is probably an oversight, but I'm Helen Wagner. I'm a senior customer success manager at Pantheon. Come on in, good to see you, grab a spot. We haven't really gotten too far in yet. So I'm a senior customer success manager at Pantheon. Part of my job over the past year and a half has been assisting customers with load testing before they do launches, and helping ensure that they will be successful on our platform. So that's kind of some of my background there. And just as a heads up, Pantheon is hiring at the moment. If you have any interest in applying, feel free to find me later. Let me know. There's a link in this deck which will be available somewhere. Chris will tell us at the end where.
That's there.
Okay, well, the deck itself.
Oh, yep.
The deck will be available somewhere. The link right there, if you click the Now Hiring, that will take you to our application page.
My name's Chris. I work for an agency called MindGrub. We're primarily based out of Baltimore. I'm an engineering manager. MindGrub specializes in Drupal, but does a lot of things beyond that. It's kind of a fun place to work. You want to close the door? Sure. It's kind of a fun place to work. We do a lot of things with Drupal and decoupled Drupal and WordPress and mobile apps and kind of some weird beyond things, like we've written some integrated code that got put onto a board that went onto a piece of hardware. We've done some robotics, some VR, a little bit of everything. Also, we're hiring. So now that's out of the way, load testing, which is why we're here. Why bother? It's one more thing we're putting into your project delivery, getting between the code you're writing and production release. And this often, when it comes crunch time, and you're pushed up against that deadline, QA is often one of the first things that gets cut. And what we found is a lot of that times that's going to be your user testing and performance testing, which unfortunately usually happens within the last few weeks of production once everything's in place, the functionality's there, your data models are built, and you've got some data seeded for it. So we're going to talk a little bit about why we bother load testing in the first place. Before we do that, I just want to kind of build a shared vocabulary so we're all on the same page with what we're talking about. Performance testing is kind of an overall term when we just want to understand how our software and our platform reacts to a given set of circumstances that puts it under a load or a stress test. We want to understand how it performs as we ramp up the stresses we're putting it under, where some of the weak points may lie, where the failures may be introduced. So kind of under performance testing, we have this concept of load testing. So load testing in this context is where we're going to continue to increase the load on a particular system so we can understand where it starts to fail. How much tension can we put on a rope? How much weight can we put on a concrete support column before cracks start to show up? How much weight can we put on it before those cracks become critical and we have a collapse? How many uncached users can our software hold and survive before we start seeing it slow down? And there's still a user experience, but it's an unpleasant user experience. And how many users can we survive with before the entire system goes down? Thirdly, and we'll kind of tangentially touch a little bit on this, is stress testing. Stress testing is where we intentionally put the system in a given known bad state, and then we start to load test it. We want to understand how it reacts to those failures and weaknesses. Given the rope example, what happens when we put that same rope that we simulate maybe a year's worth of wear and tear on, put it under the same kind of load test that we do a brand new rope? Can it still handle the same workloads? Can it still handle the same weights? Does it freight earlier? The same with software. What happens with that blog site that we launch for someone when we simulate a year or 2 years worth of editorial content in it? Can it survive the same load test that we're simulating for a year after launch? Are we setting them up for a catastrophic failure 2 years down the road? So it's a lot about putting the system in kind of a known uncomfortable state and then seeing how it reacts once we start to push it up against that uncomfortable edge to see what happens.
One thing I'll add there too is it's not always necessarily even like a time-based component. It's things like, hey, we're dependent very heavily on Solar and Redis on this site. What happens if the Redis cache gets flushed, in the middle of peak performance? Is everything going to just fall over dead? Because you're suddenly putting a ton of weight on the MySQL layer or whatever database layer you're using. So those are like additional things that you can check and plan for.
Cool.
Okay. So I'm going to start talking about a couple basically stories here about like where load testing has been important, or as I'm sure a lot of people in the room know, where it has perhaps failed, and how load testing may have been assistive in this. So Healthcaregov obviously is a very high-profile website that was launched and didn't work as expected or intended. There were a lot of things that went into this. So if we could have next slide real quick. Basically, some of the statistics that I was finding when I started researching this more and more was that they had 25 or 250,000 users on the site, and so the site crashed within 2 hours. The way that they had set it up, initially the plans were people could come in, they could be unauthenticated users, they could navigate the site, get quotes, whatever they need to do. But then somewhere along the line, the design changed. Everyone had to log in. The people who built the logged in system for authenticated users weren't planning on having the full load, so the site couldn't actually manage authenticated users very well. So basically the end result was they only had 6 people able to actually complete their form submission on day 1. And then it took them months. I believe the site launched in October. December 1st, they were finally able to handle 35,000 concurrent users on the site at one time, but that was just not enough. It wasn't good. So some of the things that contributed to this launch fail, as we'll put it, was that the launch date was actually mandated in law. So it didn't matter what state the site was in, it was going to go live on this date. So what that meant is the site launched not feature complete. They were able to do minimal testing, minimal troubleshooting, probably weren't able to do load testing. I couldn't find whether or not they did actual load testing. But at the end of the day, it also didn't matter what the results were that came back. The site was going to go live. So that's a situation that we want you to not be in. So when I recommend not having your launch date mandated in law. But on the other hand, we also want to make sure that you're planning your schedules for these launches so that you can actually take into account the ability to test and troubleshoot. And then if you do find something like, oh, hey, a bunch of authenticated users is going to bring our site down, that you actually have time built into your system to actually fix that.
I feel like this has had an interesting effect outside of the technology sphere, specifically Healthcaregov. A lot of the podcasts I listen to outside of technology, some political commentary, when they launch a new IP or a website within the government, a lot of times the analysts' expectations are that it's just going to instantly fail because that's what technology does. So we're again trying to prevent a healthcare.gov and kind of change the overall mindset that we don't want to be responsible for one of these products that continues to set this kind of false narrative that this is what technology does, this is how it's supposed to work.
Yeah. So another situation that I came into, so this is a little bit different in that it wasn't necessarily part of a launch, but one of my customers had a Drupal site that had a major Salesforce connection. So it's a website for a foundation that's driven primarily based on donations. So users can log in, get news, they can make donations, and on every login, the user was going to have their Salesforce data pulled into the Drupal site. During this process, though, they did all their testing, they pushed everything up live, and then when it actually was starting to be underneath the load of the actual user base, all of a sudden we were seeing lots of very weird problems. Data wasn't loading, the site was going down, you would have connection timeouts, sporadically as things were going on. And the problem here was it was really difficult to figure out what was going on because it was a production site and they didn't want to, DDoS their production site to force it to crash. And then they also didn't have 100 people that they could just have sit down and start logging in at the same time to see if it was related to the amount of users on the site. So what we did is we sat down and looked at this and said, okay, We suspect that this is related to your users logging in because we could look into Relic and see that the Salesforce was the external service that was taking a really long time to load. So I sat down with the developer and we designed a load testing script that would actually simulate users logging in and out so that he could create an infinite number of users, however many it was that he needed, to put this site under load. So then we cloned the site so that we weren't actually hitting the real site, had it in a duplicate of the production environment, and started load testing that. So the benefit here was we could control all of the variables. We could see in real time what was happening in New Relic. We could see, is it happening with 5 users, 10 users, 100 users, 200 users? Where is this breakpoint? And then the other great piece was, once we kind of thought we had identified where the issue was, he could roll out the fix, and then we could test it and make sure it worked before he went back to his customers and said, cool, found the problem, it's all fixed, everything should be really good to go now. It was also very awesome for me because I could hand him the script after we had it started. It was easy to set up Locus on his machine, and then he could make tweaks to the script as he went. Because he was like, oh, hey, I actually want to try, hitting this specific place in there. All right, cool, just change line 50 and you'll be all set. So it was a really great way for him to be able to own that process and not necessarily have to involve me. Yeah. Anything you wanted to add on that?
No.
Okay. So then the last kind of user story, so this is a launch load test success story, which is great. I had another customer that had an international site. They're seeing about 50,000 anonymous users per day. It was largely a static site with mostly evergreen content, so an occasional update from marketing or just new content, but not frequent. And so they're building out this site, and we're totally expecting everything to be perfect. Like, this isn't a complicated site. It's going to be fine, right? Well, what we discovered, this was a redesign from D7 to D8. I feel like I should clarify that as well. So it was a relaunch into Drupal 8. They had kind of, in the last month or two of the process, the curveball thrown that the site had to be GDPR compliant. We needed to put one of those cookies pop up saying, yes, I understand there's cookies on the site. They did everything right. They added this in here. They came to me a week before launch. We set up their load test. We went ahead and ran it. And if we can do next slide. Thank you. The load test results came back showing really bad performance. And we were all a little shocked because we're just like, whoa, we're seeing like 2,500 millisecond application server response times. 800 is like acceptable but not good. 400 is kind of where we try to tell our customers that's how fast you want your application servers to be responding to requests. So 2,500 was not great. The actual experience on the site for the total page load times and stuff was pretty cruddy. And we were really confused about why this was happening because it wasn't a complicated site. So we started looking into things. I started pulling, caching headers, pulling our cache hit rate metrics, and we discovered that their cache hit rate was less than 5%. And we were really confused then because Drupal 8 caching is easy. It's actually pretty cool. What we turned out, or what we were seeing too then in like New Relic and other places, is that the site was running out of PHP workers. My SQL layer was working pretty hard. All of this kind of makes sense with the low caching. What we discovered, basically upon more investigation, is that the way that they had implemented the GDPR cookie pop-up was somehow creating a cache, but it was creating a cache based on each individual user. So instead of having caching for the site, each individual user had their own cache. So the first time anyone visited the site, it had to create a cache, and you weren't getting a cache hit because it was tracking those cookies and tying that into the cache. And it was a very weird problem. And they were able, fortunately, since we did the load test a week before the launch date, they were able to go in, dig into this, figure out that there was a problem, start looking for different solutions, get this implemented, push it out the door. And so when we actually put the site live, everything went smoothly. We got the application server response times back down. MySQL wasn't done happy. Didn't need to increase the number of application servers to make sure it was successful because caching suddenly worked again.
I think that's a great point. As from the engineering side of the equation, as with all things, they're cheaper and easier to deal with when we catch them in QA rather than the client or we're catching them in production. Anecdotally, I feel like unnoticed performance scaling issues are some of the worst things to troubleshoot in production. Usually that's the system's at a critical state or down, and we're trying to scramble and debug and solve solutions like this. This is one of, in my mind, and I fight for this pretty avidly on a lot of our projects, this is one of the most important QA metrics that we need before a launch and even iteratively over a project's lifespan so that we're ensure we're not slowly creeping up on one of those scalability issues we could encounter. So we talked about what goes wrong when you don't load test, and given the title is how to successfully launch without headaches. So let's talk about when to load test. Obviously, we want to load test at new launches. We're more or less code complete, we're feature complete, we have an idea. All of our production layers are hooked up, whether we're running on Pantheon, within Kubernetes, Apache Nginx, we have our production environment set. We've got a test build. We want to see what that runs like on as close as we can get to the production configuration to our hardware. Also, major feature releases. If we're doing some kind of large change to the system, it's worth, again, going back and running the same load test, especially with some scalability. Sometimes this could introduce some unintended consequences, especially when it comes to like some cache-breaking features or some data architecture decision. Bug fixes, it's still, again, good to run this on an iterative scale, and this is one of the things we like about Locus. Once we have the test set up, it can very easily boil into our pipeline. In our case, it's not something we run over every single merge request that goes up. It's something we try to run at least every sprint, but we run in regular iterative changes so we make sure that we're not negatively impacting the performance of the production application based on small bug fixes that are going up or the normal sprint work. Something unrelated to any of the development cycle, test around major marketing events. We actually have a client right now that we inherited that is an e-commerce site that is failing by success. They have a moderate amount of customers, but they've hit this special niche, and they found that when they do their marketing blast and they put a product on sale, where a lot of people have to come and it's authenticated traffic, it breaks through the caches, their site instantly goes down. Every time they send out one of these marketing blasts, they have too many people that want to buy their product. And we're working to mitigate that, but one of the reasons we inherited this is because they didn't have load testing, they didn't know how much their traffic load would increase. They were perfectly fine for 2 years. They started this new niche marketing campaign, and they can quadruple their traffic within a 5-minute span and take their site down every time, which obviously is catastrophic to their business model.
One other kind of example of that is with like regular sporting events. So I work with a large equestrian sporting event, and they have reasons for on their site why they specifically cannot cache certain pages. It's a known issue, it's a known blocker. Unfortunately, because of the nature of the sporting event, the information that's being shared on those pages is like up to date, up to the minute statistics. And so the people who are interested in this information, fortunately, don't care if it loads slowly, they just need it to be accurate. So we physically cannot cache these pages. So what we do every year leading up to this is we'll run a load test, a performance test, and see basically how is this holding up? Has it changed any in the intervening year? What was our traffic like last year? How did the site perform? So that we can proactively increase the server resources if needed to try to help mitigate any potential risk because obviously downtime during a major event like that is catastrophic. So instead of having to be reactive, like in the situation with e-commerce, doing this performance testing, this load testing helps us be proactive to make sure that the site can stay online during the incoming onslaught.
I talked about this a little bit ago. We like boiling this in the CI. Once the work's kind of done up front, it opens it up to the entirety of everyone on the team. Some cases, it's anytime we interact with the code base, we can run our automated test that runs our performance test. Other times, some of our CI pipelines are just a button within GitLab that you can press. A couple of them go so far as we have Slack commands that integrate with projects where literally anybody on the project, even like the ED or the account manager, can come in and run some of these to get an idea of the health of the metric of the site. We don't like really gating that information behind the one person that has access to Google Analytics and the one developer that wrote this Python script that sits on their computer somewhere in a folder on their desktop. And kind of what we alluded to earlier, debugging issues that can occur under load. Obviously a good time to circle back to your stress test. So testing plan is kind of a critical piece of this whole process. This is not specific to performance testing or load testing. This is just something you should have on your site. Depending on what your specific project is, the scale of it, the team, this is going to differ. How important is usability testing? How important is unit testing? All of these have different values on each project. This usually should happen at the beginning of a project, and this would be where you decide how you're going to handle performance testing, what you want to account for. Is it useful or probable that this site should at any point in time be able to 5x their expected traffic peaks just to account for anything? Could it be 10 times, 15 times? This would be where we would have that decision, and it's usually just a README or somewhere in our Confluence that we can always reference back to if we know the guidelines we're trying to maintain and hit, and when we think it's important to test. Maybe it's a project that will never have marketing campaigns, but we want to run their performance testing after every major sprint feature release. So that's where a lot of that would happen. I think just having a plan at the end of the day is the most important part. Have a plan, execute it. End of story. Having a plan at the beginning of a project also helps guard you against that budget crunch of we're running up short, guys. We really need to cut the QA budget to get these last few features out the door. So we talked about performance testing and load testing in general. I want to talk a little bit about why we chose Locus specifically. There are a handful of other tools. In the past, we've used something called Siege, we've used JMeter, we've used BlazeMeter. All have their various strengths and weaknesses. So the reason I chose this specifically over JMeter is I'm not a fan of writing XML for configuration files. I'm also not a fan, if you ever use JMeter, it's kind of clunky, you go through the UI, and maybe it's irrational, I just don't like writing XML files, so I wasn't a fan. We also liked how it had distributed scalability. So Locus can hook up with secondary and slave runners, which also ties well into Kubernetes. We have a lot of Kubernetes products that we run at MindGrub. So if we want to go beyond what the physical capabilities on my machine can handle for generating hundreds of thousands or millions of users to see how one of our products reacts, we very easily can do that. It works well with Kubernetes and Helm charts and can kind of shard a test run against many runners and then aggregate the data back together, which we found really beneficial.
And I'll add in there that Pantheon actually almost exclusively runs our load tests out on Google Cloud Platform using a scalable thing, because if you've got a site that's getting 5 million views a day and you need to stress test it, that's an awful lot of users that you need to throw at it at once in order to actually stress test it. I have run load tests where we had 200 Kubernetes containers up and running and hitting it with, I can't remember how many users and requests per second we were hitting, but it was pretty astronomical. And it's kind of amazing that you can just kind of type a couple commands in your terminal, push something up, and boom, you're suddenly hitting a site with, 1 million requests per second.
And to that point, when it comes to distributed scalability, some of the advantages we think Locus had over JMeter and Siege specifically was it wasn't thread locked. It has Python's concurrency models built in, so I think it lends itself to scaling a little bit easier, even when you want to run it on your computer. Again, I really don't like XML. I really dislike having to pick up some new domain-specific language just for the tool we're using at that time. And I hate asking my team members to pick up learn this new domain-specific language, XML, for this tool that isn't transferable. It only persists so long as that tool persists. Whereas Locus is 100% just writing Python code. I think that's a better cross-disciplinary skill for our testing engineers to have and is useful elsewhere, rather than this person is now landlocked with their skill set into this one particular tool until we decide we don't like it anymore. And we honestly like Python. We have some Flask projects and some other Python work we've done. Our DevOps folks, being DevOps folks, obviously love Python. And it's open source. That was important to us. One of the tools I mentioned was BlazeMeter, which is a wonderful product. We've used that in the past. That gets really expensive. It's a hosted SaaS product. It's wonderful and it's easy. It's just we have a hard time justifying the cost sometimes to the clients and the projects. And rather than splitting between some clients that were happy with an additional cost for BlazeMeter and some that were happy with Locus or other tools, we try our best to unify all on Locus. I know Pantheon almost exclusively uses Locus for all of their load testing as well.
It's not even almost, it's exclusively we use Locus.
I guess I should mention too of Migrant and Pantheon work hand in hand on a lot of our Drupal projects. It's not exclusive. Again, we do a lot of weird things with Drupal.
We work with a lot of other agencies too.
Right. Pantheon's wonderful. So a lot of times we're load testing within Pantheon's infrastructure. It's wonderful. There are times when, for specific reasons, we go outside of Pantheon. We've got a lot of projects hosted in AWS within Kubernetes and other complicated hosting infrastructures where we'll still rely on the same tool set.
And with Acquia as well. And I mean, you can mention them. It's okay.
That's fair.
You don't have to not mention them because it's Pantheon.
Okay, we'll see how this works today. Live demo time. Well, it's testing. We tested it, right?
Yeah, we did test it.
So I like how approachable. Again, Locus is all written in Python. I hope that's legible. I tried to make the font as big as I can. Really simple. The entirety of this Python file, the Locust file, is going to run a test case against our site. In this case, the mindgrub.com test environment on Pantheon. But you can see we just need this website. We need this one class that's going to look for to define a task set, which is just, think of it as Python's list of tasks that we're going to run. And they're pretty straightforward. It ships with an HTTP client, which is how we interact with sites most of the time. It's not actually emulating a browser, pulling it up and navigating to the page, though we can do that. It's just most of the time for our load testing, that's not needed. If it is needed, we can tie in Casper.js to emulate actually loading a browser and interacting with some JavaScript elements if needed. But for the most part, the HTTP client works wonderful. This is kind of the bare bones. We're just defining a few tasks to go out and hit a handful of pages. So let's see what that looks like in practice. So I'm running Locus through the web UI. It ships with the web UI, which we kind of liked as well. Some of our team works really well within the web UI components. It also can run headless, and we can stick it in a CI pipeline and extract the information out that way. So all I've done is I've run this Locus file that I've defined. It should spin up a little local web server that I can access via the URL. I will give it the domain that I want to hit, which, by the way, this is our website. It's yet another agency website, nothing special to it. So I'm going to give it the host. I'm also going to give it the number of total users I want to simulate. Let's put it at 50. And hatch rate, the hatch rate is just how fast I want to add users to it to simulate how quickly the traffic spikes occur. With Pantheon and with a lot of other infrastructures, we will start warming resources up once we hit certain thresholds, so we can kind of dial this in to see how quickly our infrastructure responds to the increased traffic load. In this case, I'm just going to add 1 user a second.
And I'll add, as far as that goes with Pantheon and the way of, like, when I'm performing load testing for my customers, we do take a look at what they're doing, what their traffic looks like, and we'll run that hatch rate at a couple different places. Basically, sometimes we'll do a slower warm up and then perform tasks like clearing the caches to see what happens, how long it takes for the site to recover. Sometimes we'll just jump in, spawn 15 users a second, let's get it up there. And obviously, if you're going up to a very high number of users per second, you don't want it to spawn at 1 user per second, because each of the workers that spawns, and this is all stuff that you can define, the way that we have ours set up at Pantheon in our script is each user spawns, performs 10 actions, and then dies. So if you're trying to get to 1 million concurrent users, if you only have 1 user spawning every second, it's performing a task every second, you're never going to hit that rate. So you have to kind of play with that hatch rate and make sure that you're getting to the numbers that you want it to get to.
So that circles back again to the test plan. It's important to simulate what kind of traffic you're going to have. On existing sites, obviously referencing Google Analytics and New Relic, any analytics is wonderful. to understand the kind of content and kind of user interactions you have. One other thing that we define in, there it is. One other thing we can find is the wait time, how long we're telling Locus to wait in between these interactions and tasks that we've defined. I'm just telling it just a random, pick one between 5 and 15 seconds, which we're simulating what the average traffic is for someone that hits mindgrub.com. It varies on the kind of products we worked before. Some of our websites are very content dense and rich and very targeted users, and the average time on page is closer to 20-30 seconds. So we would obviously alter that to reflect what our goals are in the test. Nope, don't want Slack. Go away. Okay, so this is running. It will just run until I hit stop because I haven't defined any time limits. What's interesting, and see if this warms up. This is actually a new relic for maybe. Nope. Okay, not everything works. If we had New Relic pointing to the right app container on Pantheon, you can actually watch Pantheon and the app container's response times change and shift based on stress, which is interesting, and that's usually a lot of times how we'll debug problems, matches up with the load test. We get some information from our load test here, the number of requests, what it's hitting, the fail percentages, and kind of our average response thresholds. If you're a more visual person, we of course have graphs. Unfortunately, Locus doesn't have a great way to export these, and these can't.
Well, you can download the data. So you can download a CSV of
right.
Everything that's happening, at which point you can plug it into, at worst, like Microsoft Excel and create graphs off of that, or whatever framework you're wanting to. Quite frankly, when I'm building out load test reports, I just screenshot the graphs that are here.
Yeah, that's exactly what I was going to say. We find the data more interesting. Our clients and some of our account managers and project managers find the graphs more interesting. We're working on trying to take the CSVs and generate our own graphs on it. But for the time being, we usually steal these from the web UI if we need to illustrate a point. But you get total requests per second, average response times, and you can also see, based on the hatch rates I put in, you can see if the user requests grow over time. Because it's the web UI, I can go in and alter things if I want. Also for fun, I turned Drupal's CSS aggregation and page caching off for anonymous users for this environment, so it does have low thresholds. But you can see I went from 25 average users at adding 1 user a second. I could, but there's no cache to clear. So you can see we're just going to continue to ramp up. I will stop that and look at something not entirely, but a little bit closer to what we are simulating for actual traffic. And this is a great one we kind of throw generically across a lot of our sites, regardless of the specific implementations. Same thing, we're looking for a 5 to 15 second time load. I'm again going to run this on the mindgrub.com test environment. Some other things we're doing here, we've defined some tasks. Again, we have access to an HTTP client. That means we can do GET request as well as POST request. Because we can post, we can easily log the user in, which we do here. I created a user today that will be deleted as soon as this is over, but I can log in on the MindGrub site and then simulate that user's traffic and experience once they're logged in. There's really no point other than illustrating it. MindGrub.com doesn't do anything for authenticated users other than grant our content editors more functionality. But some other differences, depending on, you can also focus in on how often you want a task to specifically be targeted with this ratio metric. You can see I've added numbers to the Python decorators here. These are all just ratios based on each other. I like to base my ratios off of 100. The highest is 100, so everything else is kind of easy for me to on the fly calculate. This is saying on every 100 page quest, this will get hit 20 times, this will get hit 50 times, roughly 50%, 20%, and I can kind of dial in to better simulate what I expect the traffic load on the site to be. So I'm specifically, in this case, I'll maybe try to call out pages I know are a little bit more performance intense, so I can simulate what the traffic load would be like on those. Additionally, and credit where it's due, this is something that I borrowed from Pantheon. They gave a presentation on this and shared this in the past, and it's something we use on a lot of our sites together. We have just a crawler that goes through and crawls starting at the homepage, crawls the entire site, finds links. We do our best to make sure that the links are specific to this local, so we're not checking links. We're not going to click or use links for telephone numbers or external URLs.
You don't want to accidentally DDoS a site that's linked from your site when
Yes.
you're doing this, which may or may not have happened once, which necessitated the adding of this. Make sure it starts with what you're doing. And there's a couple different ways that you can achieve that. That some of them are more elegant. I had a way better way that I was doing it for a while, and then I don't know where it went.
So, I mean, with any testing framework, we again have setup and teardown functions, so we can run this. We're not specifically running it on setup. We could. But we're just going through, we're building a Python list of URLs we want to hit. And we have a task specifically as an anonymous user, go through that list and crawl and hit those pages, which is wonderful. I have this targeted at 75% of the time. Beyond me wanting to specifically target pages that I know and think are going to be problematic, I can also have it just generate random traffic hitting the site as well. So...
While he's getting this pulled up, one other thing that you can do with this Locus file, search is obviously a heavy operation on sites if it's not cached properly, if it's not used frequently, so the cache expires. You can also, using a similar structure here, we have like listed like the top 1,000 most common words in English language. We also have various multilingual options that are common that we can pull in, where you basically can identify what is the search URL, put that into the query string, it attaches a random word to the end of it, so it'll start hitting search. So you can also throw in, based off of Google Analytics or whatever you're looking at, like if 5% of their traffic is using search, you can try to have 5% of the traffic during this time frame also utilizing the search functionality, so that you're getting a full picture of what's going on.
That right there is why I prefer Python over XML for these scenarios. A lot of our sites are behind, at times, complicated two-factor authentication and CAPTCHAs. We found it easier to deal with when we have Python and we can go in and manipulate the code rather than relying on some abstraction XML layer. It is possible in other tools, but we found that it was more empowering to our engineers to do it in these tools. So here I am, I'm just running the same task. We're still hitting mindgrab.com, but the difference is we're now simulating authenticated and anonymous traffic. It's HTTP, you can see what kind of request it is. We could build we could build this specifically for any application, kind of just with this. And I think it actually, one thing I do want to call out is we can specifically in that data export we get, we don't have to filter through all the noise of positives, we can just focus in on the negatives. This specifically is a page that doesn't exist. It's not a 200 status code of any kind, so Locus is going to call it out as a failure. We can go through and parse this and figure out what's going on after these tests run. Cool. I will stop that.
And in other, situations, there's a lot of different situations where you would, that you can create for the load testing. It's very common for us to do like e-commerce workflows because, as Chris was mentioning with his site where they're getting killed by success, we aim to not have our customer, you try not to do that. So if you do have an e-commerce site that's expecting significant amounts of traffic, we will set up an e-commerce workflow. We also have like learning management systems, LMS systems where people are doing, the word just left me, but if they're purchasing a course and they want to go in entitlements, they're doing entitlements for different things. You can test that the entitlements are working correctly, you can test that the videos are loading, you can test the experience of like a student logging into the LMS and being able to view the content, going through e-commerce to purchase the course, making sure that the entitlement is granted, they can actually view the course. You can also go in and create administrative users or teachers and be able to test all of their back end for the site as well, and like all at the same time. So you can get like the proper ratio of student to teacher to other administrator who may be involved to again ensure that your system isn't going to fall over when all of these things are happening at the same time. And that it's working correctly.
I'm going to talk a little bit about that system falling over. So while I'm recently familiar with load testing, I was working on a project with background, it was a Drupal site. It was an interesting to work on as an engineer. It was a Drupal site that had been under active development for 5 years with at least the smallest engineering team they had was 3 to 4. It started as a kind of startup, and they had moderate success. They were growing continuously. Effectively, it was just a catalog of data. All of it was gated behind user authentication. I mean, most of it was uncached. Unfortunately, it was very sensitive up-to-the-minute data, so it was important that we couldn't cache the data for more than 60 seconds at a time. Most of the time, we could get away with caching it for about a minute or two per user session. It was unique and different for every user that logged into the system. Not a big deal. We think Drupal worked well for it. It was originally built on top of organic groups. It was a paid subscription service. This was their entire business model, was gathering this data, manipulating it, and granting their users access to it. Again, 4 or 5 years old. Moderate success. The entire growth of the site was they're requiring more users to view the data. They're also requiring larger sets of data for those users to view and consume. Not a big deal. Until about August of last year, we had a 5-minute blip show up within New Relic, and it sent alarms to everybody. Everybody got the emails. We got Slack notifications of, hey, the site went down. Why? Because all of your EC2 instances, which are just our virtual servers, and your MySQL servers all were at 100%, and they died. Okay, that's weird. We tried our best to reproduce it. We couldn't. We started throwing some initial load testing on it. Couldn't. Another interesting of this project, the client and the startup business owners were entirely dictating the pace and scheduling. So when we said we're concerned, we'd like to do more testing, they said, sorry, we've sold more features to clients and they're expecting it within 2 weeks. So we said, okay, we can't reproduce it. We tried. Here's an incident report. We can circle back if it happens again. Okay, that was August. September, it happens again. This time it is for 2 separate 10-minute periods. Same thing. Can't figure out what it is. Aren't sure what's going on. We spent a day or 2 investigating. Can't really make heads or tails on it. It's not something we're able to reproduce. Circle to November last year. We get the new Relic Alarms, and these are our RDS server CPU usages, which are MySQL servers. We have 3 running, 1 writer, 2 and 2 readers, so we can scale accordingly, we feel. This arrow is because I find it comical that when Amazon gives you your CPU usage, they have 120 up there as if 100% is not enough. What are the servers doing? So you can see we hit these peak usages. It was very abrupt, very sudden. We had a couple spikes. We were trying to investigate, and suddenly we hit this 100% CPU usage. We don't know what's going on. We cannot recover the site. We can shut down the EC2 instances and restart the MySQL servers. As soon as we let people back on the site, it happens again. If we shut the site down and put it in maintenance mode, don't allow anybody to log in, it works. As soon as we remove maintenance mode, it's back up. MySQL is saying, hey, there's red flags everywhere. All of your EC2 instances are hitting 100% throttling for CPU and memory consumption. Same with your MySQL servers. So at this point, we're in panic mode because the product's down. The product's down for many days, and finally we have the client's attention. It's time to fix this, they say. Wonderful. How do we fix this? Oh, by the way, for the record, when I say MySQL servers, we're running on RF4 larges. So those are each of those 3 has 2 CPUs with 16 gigs of RAM. I've never thought much about it because we've never hit beyond that scale. I know this client has a large data set. Their data set largely is contained to 1 large, we're using ECK entities, not with a lot of field. We have 1 table that has about 6.8 million rows, which is interesting. It's doable, it's feasible. We've dealt with this before. But we abruptly went from 0 to 100 real fast. So we're in full panic mode. More app containers, we think. That's obviously the solution. We recently switched from EC2 to Kubernetes, and inspecting, we would hit the situation one day. All of our app containers are at 100%. Obviously, let's remove the max threat, or the max amount of containers we can have from, I think it was 3 or 4, because we've never used more than 2. We remove it entirely and let the nodes go as high as they can. We go from having 3 app containers to 98 within 5 minutes, and find out the only thing we have done is effectively kill the site faster, in a repeatable manner. So excited. Kind of evidence, but client's not happy that that's what we report back. Okay, now I've got all of the app containers. All we can do is kill it faster. Client's approach to solving this was obviously we'll just throw money at the problem. That's how you fix everything with infrastructure. Who cares about the code? Let's throw more money at MySQL. We go from our 4 larges to something called 8x larges. That is just doubling 4 times the size of the databases we're running on. Each one of our databases has 16 CPU cores now and 244 gigabytes of memory. Oh, and by the way, it went from 3 to 6. Cool. We've still not solved the problem. We've built us some leg room. If we scale the app servers back down to about 4 to 8, all this does is gets us through about an hour before we hit the same problem. Still not sure what's happening. Interload testing. I don't unfortunately have the load test from Locus, which we felt was easier to maintain. Again, we're in panic mode. We're using JMeter. But we start going through load testing once we finally start digging into the meat of it. And this is really what saved us. It was a combination of load testing with our AWS monitoring and New Relic to kind of hone in on what was happening. This is one of many of the queries that suddenly became an issue. And I'm going to have to scroll because there was no way to fit it all. Okay, this is normal within the Drupal space. A lot of fields. Oh, okay. We've got a subjoin with a count and some case conditional and some if statements and some math on some more joins. Oh, and where and group by. Oh, more sub query. Oh, okay. We keep going. The tables make no sense because I've sanitized it. But okay. So this is a problematic query. Cool, we can fix it.
But can we fix the slides?
Nope. Cool, we can fix it. We fix this, we find more. We've just opened the floodgates. Oh, by the way, this query that we find the appropriate database logic to has this comment over it, which I absolutely love. It's been there for 5 years.
For people in the back who can't read it, it says, as far as I can tell, this just works, but I have no idea how. I'm scared to touch it.
It's just work. No one touch it. Yeah. Resolution to this entire epidemic was effectively that 6 million, it was 6.8 million row. We were fine. We were running a lot of queries that are effectively scanning it x times y times z, which was fine because for the longest time, x, y, and z were a value between 1 and 3. It was slow, but acceptable. Overnight, those values increased to between 100 and 900 each. So we're multiplying all 3 of those together, and we're scanning this $6.8 million row table each one of those times. And oh, by the way, while we're panicking, when you in AWS, when you 4x your database resources, it also 4x's your AWS bill. So we now have the most expensive AWS bill per month compared to all of our other clients, what they have per year. Lesson here, again, this was a really problematic. They had a lot of problems with client relations. They lost some sales. They lost some clients. They had to deal with a 6-figure AWS bill for a 3-month period while we worked through this with them because they kept axing and kicking and refusing to focus in on performance testing, and we didn't have performance testing in place from the get-go. So again, this is important. It has real-world consequences. Healthcaregov going down cost millions of extra money, unfortunately, to the taxpayers, but these have consequences. There are real-world wins we can get out of this. To sum all of it up, in conclusion, skipping load testing is bad. Please don't do it. We think it's pretty easy to at least set up some base sanity checking in place and stick it in a CI. It at least gives you some idea and prepares you for some of the catastrophic events that can occur. We feel Locus is amazing for reasons stated. Here's a link to the slides. I put all of my slides on GitHub. They're in Reveal.js. If you want them. Yeah. I'll post these on the Florida Drupalcamp website, but the slides are here. It's open source because that's what we believe about. So if you want these, you can take them. I have actually had people do this before. If you disagree with something, you can make a pull request to a slide and we can update it.
We will also accept any typo fixes that you find.
I've had multiple pull requests for that. Here's documentation to the Locus notes if you're interested to go get started. Doesn't matter what your infrastructure is, if you run Python native locally, if you want to run it in a VM, if you want to run it on Google Cloud and Docker, they have a lot of that figured out for you, which was exciting for us. And finally, just go forth and do awesome.
questions from anybody? Yeah.
Was the healthcare.gov example, was that a Drupal site?
It was not.
It was not. That was just a very high profile, publicly available use case of stuff went horribly wrong because nobody had time to test. Yeah. Any other questions, comments?
How long did it take you to bring availability back?
It was 8 days before it was painful to use the site again. And it was crippled functionality because we had to give it back up. It took us about 3.5 weeks to work through. That was one of the painful queries commented that way. There were maybe about 12 or 15 we had to go in and refactor and reverse engineer what the logic that went into it was and rewrite all of that, with the client obviously very upset at us. It was fun.
Was the original code from the company?
Do what?
Was the original code that caused the issue written by you guys?
Yes. Ultimately, yes. It was written by us 5 years ago, which I don't know if any of you have ever seen code that you've written 5 years ago. The other interesting bit with this was we constantly switched teams out. So at this point, it was written by a team that had moved on to other projects and weren't around to come and tap and ask them, what was this?
Yeah. Please explain your work. 5 years
Which
ago.
is obviously an example for having better code practices in place, but everyone learns and grows as you go in a bit.
All right. Well, we'll be wandering around.